Okay, this is second part of the notes for Unit 5, Algebra 3, Section 2.6, Combinations of Functions and Composite Functions. In Part 1, I did combinations of functions. That's adding, subtracting, multiplying, and dividing. The second part, we're going to talk about composite functions or composition of functions. Composition of functions are when you replace one function with another function. So what I'm going to be doing, or I should say not one function with another function, you're replacing a variable with a function. You're combining two different things. So the first example I've got, I'm given f of x equals 3x minus 1. And g of x equals 7x plus 2. And I want this f of g of x. So this g of x, which is 7x plus 2, is going to go in here for x. So where this x is here, I'm going to replace it with a 7x plus 2. So right here, that x is going to be replaced with 7x plus 2. So f of g of x is going to equal the 3, replace this x with 7x plus 2, minus 1. I'm just going to clean it up algebraically. So I have f of g of x equals 21x plus 6 minus 1. So f of g of x equals 21x plus 5. I can also go in the other order. So now I have g of f of x. So now the f of x, which is 3x minus 1, is going to be into this function for the x. So 7 multiplied by 3x minus 1 plus 2. So g of f of x, I'm going to take the g, but instead of x, I want to write 3x minus 1 plus 2. Distribute, so g of f of x is equal to 21x minus 7 plus 2. G of f of x equals 21x minus 5. In this case, they're very similar. One's a plus 5 and one's a minus 5. And you might think, that's not a big deal. It is a big deal. Would you rather borrow $5 from somebody or loan $5 from somebody or to somebody? The other format for this, and I don't usually use it, this f open circle g of x, that's not a multiplication. Some students refer to it as fog. That also means f of g of x and g of f of x. There's not an SOL for this course. I type up all your assessments, so every quiz and every test. I don't use this form because students will tend to think that's a multiplication. So whenever I type anything up, it is this form. But if you see this in another format on something else, maybe when we do Delta Math, quizzes, SATs, something like this, you do need to understand that this and this are equivalent. Here's another example. So now I want to find f of g of x, but my functions, f of x has two different x's in it. G of x is 2x minus 5. So this is where I have to be careful. I'm going to take this g of x and put it in here. So I'm going to have f of 2x minus 5 is going to equal 2x minus 5 squared plus 3 times 2x minus 5. So this is f of g of x. F of g of x is then going to equal 2x minus 5 when I square it. And you have to be careful. This is saying 2x minus 5 times 2x minus 5. And you've been doing these since Algebra 1, so at this point I'm going to go a little bit faster with this. But when you're doing it, just be careful and get it right. 2x multiplied by 2x is 4x squared. 2x multiplied by negative 5 is negative 10x. But then I have another one of those, negative 10x. So I have negative 20x. Negative 5 multiplied by negative 5 is plus 25. Excuse me, to distribute to 3, so I get plus 6x minus 15. So f of g of x is going to equal 4x squared minus 14x plus 10. You could factor that if you want. I don't find any reason to. We're not doing anything with it, so I'm just going to leave it like that. Now if I wanted to find g of f of x, so that means f of x is x squared plus 3x. I want g of x squared plus 3x, which is going to equal 2 times x squared plus 3x minus 5. So g of f of x is going to equal 2x squared plus 6x minus 5. And it stops right there. We can do these with numbers as well, and there's a couple different ways to look at them. I don't know that one's easier than the other way. I'll show both ways because I get half the students like one method, the other half like a different method. So if I'm looking at this, I want g of negative 4. So I first find negative 4, or first find g of negative 4. G of negative 4 is going to equal negative 5 times negative 4, which is 20. Then I'm going to take this 20 and I want to find f of 20. F of 20 is going to be 2 20 cubed plus 6, which is equal to 2 times 8,000 plus 6, 16,000 plus 6. So seems like a really ridiculous number, 16,006. Not that horrible. That is going to be f of g of negative 4. Or some of my students see it all in one step. They want f of g of negative 4. So they take the negative 4 and put it in here. So negative 4, or negative 5 times negative 4, make that negative 4. Then they take this whole thing and replace the x with it. So I'm going to put brackets around this, cube it, put a 2 in front, and 6 out back. So this will give you the same result. I don't care which way you see it. Go ahead and do whichever way makes more sense to you. So if I want to do this one, g of f of 0. So I think of this, I'm going to do it in stages. I'm first going to find f of 0. F of 0 is going to be 2 times 0 cubed plus 6, which is equal to 6. Then I'm going to take this 6 and I want to find g of 6. G of 6 is equal to negative 5 times 6, which is equal to negative 30. Or if you see it all together, g of f of 0, I find f of 0, which is 2 times 0 cubed plus 6. Take that whole function and put it into g, so negative 5 multiplied by all that, and I would get the same answer. Pick which way you like better, which way makes more sense to you, and stick with that one way. Don't switch back and forth. It's easier to pick one method over the other. There's not any purpose for one over the other, just whatever makes more sense to you. Now we can do these graphically as well. So here's my sheet from the first notes. And this is a graph. F of x is in blue, g of x is in pink. And here's my functions that I did before. These were all combinations of functions or operations. I added, subtracted, multiplied, or divided, and then I multiplied. So now I'm going to do compositions. So the first one I want to do is going to be f of g of 1. Okay, still working from the inside out. So the first thing I want to find is g of 1. So I come up here where x equals 1, and I go to the pink function because that's g, and I get negative 4. So that means I want f of negative 4. Then I come to the negative 4, and I move up to the blue function, since that's the f, and I get 4. Let's do g of f of negative 3. So first I'm going to find f of negative 3. Here's x equals negative 3. I'm going to go to the function, the blue function, because that's f, and I get 5. So then I want g of 5. 5 is here, I come down to the pink function because that's g of x. G of 5 is equal to -1. The seventh one I want to do is f of -5. Well, that's different. Still possible though. That just means I'm taking a function value, plugging it back into the function. So I want to first find f of -5. Here's -5. F is the blue one. I get 3. So f of -5 is 3. So then I want to find f of 3. Come here to 3. Go up to the blue one. I get f of 3 equals 3. And we'll do one more. Let's do g of 0. I know, a little ridiculous. Let's see, make sure parentheses match up. This parenthesis goes with this parenthesis goes with this parenthesis goes with that. Perfect. So I'm going to work from the inside. G of 0 is -4. So I want g of -4. Just whittle it away from inside out. G of -4. Here's -4. Go to the g. G of -4 is equal to -2. So I want g of -2. Then I go to the -2, going down to g again, and I get -3. I can make these as complicated as I want, but that's not my goal. Really just making sure that you understand this concept. And the book problems will get more difficult, but we'll do enough practice without the book as well, and those will be the type you will see on the quiz and the test.